The homework question was to find the molecular shape of a combination of hydrogen, carbon, and nitrogen. Today is the 15th. Yes, I heard you saying that. I'll try to remember that. Okay. All right, so hydrogen has... I hope you got your homework exchange, because you can't get credit for it if you don't. Either give it to me to grade or exchange it with someone else. So we've got hydrogen. You want me to grade yours? Okay, you don't want to exchange with another student? They can still exchange. You could exchange with whose paper do you have right now? We'll just exchange that. Give her theirs, and you take this one. I mean, unless you want me to grade it, I'll be glad to grade it if you want me to grade it. Okay, just want to make sure.
What did she want you to do it?
I just said so.
That's why she handed her papers to you.
Okay, here's the question.
You just didn't want to grade the paper.
Will you just be patient and listen to me? If you want me to grade it, I'll be glad to grade it. However, if all you're doing is you couldn't easily locate somebody who hadn't already exchanged papers, well, that's a different matter. I'll be glad to grade it for you if you want me to. Okay.
What's today's date? The 15th for tomorrow.
All right, so how many dots do you put around a carbon?
4.
How many dots do you put around a nitrogen? Now, you can put you can pair the last dot up any place you want to. Okay, it doesn't matter where you pair it up. I want to pair it up here because I already know, having done this a few times, kind of know where it's going. All right, let me find the difference. No, I'll use this one. Okay. All right, so I can share these 2 electrons, and that gives hydrogen the 2 electrons it needs to be as stable as it can be. I can share these 2 electrons, but that only gives carbon 6 electrons, and it only gives nitrogen 6 electrons. So I need to be able to share more electrons to get carbon up to 8 and nitrogen up to 8. So we can share these 2 and these 2. All right? And that is called a triple bond. Then from this, we're going to go to the Lewis dot formula. And we're going to squeeze the shared electrons in between the symbols for the atoms. So there's a pair of electrons between hydrogen and carbon. And how many electrons are there between carbon and nitrogen? 3 pairs for 6 total. And then there's a lone pair of electrons out here on the end. Okay? Now, to find the molecular shape, you don't really have to find the Lewis formula, but I'm going to give it to you anyway, just so you'll have the example here. All we have to do is draw a line for every shared pair. Only the shared pairs get replaced with lines, not the lone pairs. This is a lone pair because it's not between 2 atoms. All of these here are shared, and this pair is shared. So I'm going to replace any shared pair with a line, and since there are 3 shared pairs between carbon and nitrogen, that's 3 lines. Okay? So that's the Lewis formula.
What if you wrote it like going down and
For the Lewis formula?
Yeah.
The Lewis formula is fine to do it that way. Okay? So you can do this. All right, that's okay. All right, you get it? It doesn't really, the direction is not so much a problem here for either the electron dot formula or the Lewis dot formula or the Lewis formula, okay? It doesn't really matter. What matters is that you get the right number of electrons between the symbols. Okay, so this is okay as well for a Lewis dot formula. All right, then from this, now the direction does matter. What we want is the atom that's of interest to us. In this case, it's the one that is the backbone of this structure, the one that's in the middle of everything. Well, that would be the carbon. It's not always the carbon, but in this case it is. So what I have are two sets of electrons around the central atom. Sets are any pairs of electrons or groups of electrons in a group around that central atom. Well, the shared pairs we said last week are sets, and this is also a set of electrons around the central atom. So there's only two sets of electrons around that central atom. So the way that you draw that to get them as far apart as possible is kind of like a straight line. You can't get any further apart than that. Yes, that's part of getting the molecular shape. Okay? All right, then, so from the Lewis dot formula, that's what you go to next. And then from this, then we're going to go and we're going to replace any sets of electrons with the atomic symbols with which those shared sets are shared. And lone pairs don't get replaced, but only the shared pairs get replaced. And in this case, all the electrons around carbon are shared. So the shape of the resulting molecule is a straight line, or it's called linear. I'm not sure I understand.
You know how you have it straight?
Uh-huh.
Can you not do it like this one at an angle, but this one at a lower angle, so they're really the same, they're still the same length apart, but just not in straight lines?
Well, they have to be on opposite sides.
Well, yeah, they are.
Okay, so you should say, can you do it like this? Like
Yeah.
that. Well, that's fine.
Okay.
So that's okay. This is okay. I am. Okay. That's okay too.
Are there different ways for the last one?
You don't have to go horizontal. You can go vertical.
What about like the one that we did Friday?
What about the one we did Friday?
Why do you take the long and the long?
What do you want to know?
Like that.
What about it?
Is it? Can we do it like that?
No,
Why?
because there's only two sets of electrons around the central atom here. Yes,
Why don't we draw a long pairs on there?
because the shape we're looking for is the shape of the molecule, and the lone pairs don't so much affect the shape of the molecule. Okay? What matters is the shape that exists between, on the axes between those atoms, the bonds between the atoms themselves. Now we have to initially take into account the lone pairs because they affect the shape. But when we reach the final molecular shape, there won't be any lone pairs on there. Okay? All right. So this is also a linear shape. This is called the linear electron pair shape.
If you skip certain steps, like getting to that,
Well, the only step that you're allowed to skip at this point in time is this one. You need to know how to do this one, but you have to draw this, you have to draw this, you have to draw this, and you have to draw that. Okay?
what's a paper?
What's a what?
C-A-T-I-O-N.
Cation. All right.
How you say the other one?
Anion. All right, so let's give this shape 5 points here. Let's give this shape 5 points here. Let's give this one 5 points. And let's give the last one 5 points. So the whole thing is going to be worth 20 points total.
What they got for arrows?
You need to show how we go from one stage to the next. It doesn't have to be arrows. Just so long as it's clear they're going from one step to the next.
Does that make like one dot?
No, if they miss one dot, then take off 1 point.